Today we're working on the Unit 3 review for Honors Geometry. We made some changes to this review since the last time that videos were recorded. So I'm going to make some new videos for the review for everything that I have time to make. Probably not the whole review, but I will do what I can. So the whole front page to the review is new compared to last year. Definitely wanted to review how you are able to know if triangles are congruent or if they're not congruent, and how you write the reasons and how you write the names. So the first set here, we are just looking at each picture and determining if we have enough information to prove the triangle is congruent, and if so, we're going to write the reason for why we're able to know. So remember, anytime you have touching triangles, you have hidden information. This particular pair of triangles, we do have some vertical angles that we could add to the image. If you use just the markings on the original picture, you probably would say HL is the reason. And if you were to add those vertical angles, then you actually have the option of angle, angle, side. So on this one, you could do HL or you could do angle, angle, side. Both of them would be correct because you are able to know the items that would make either of these reasons. Over here, we have vertical angles in this image as well. I'm going to give them a double mark because I already have angles with one single mark in there. The triangles are marked in a matching way. That's the first thing you check for. Then once you decide if they are marked in a matching way, then you look at just one of them to come up with the reason. This one should be angle, angle, side, because we have two angles and we have the side that is not between them. In order to be ASA, it would have had to be this side that touches both of the angles. Since we don't have that one, that's why we put AAS, putting that side on the end rather than in the middle. In this image, we do have some vertical angles, but that makes angle, 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 and angle, angle, angle is not a reason for congruence, so these are not congruent, or we don't have enough information to tell if they are. The last one in this group, we have two angles and one side, and the side is not between them. So this is AAS for the reason why those are congruent. None of these have letters on them, so we're not writing a congruent statement. Let's jump down to question 2. Same thing, we're going to identify if they're congruent and why, but we are also going to write the congruent statement. So on the top line, I'll put the reason why I know they're congruent, and then on the bottom line, I will write a congruent statement. For the first set here, they share this side, so we can mark that shared side. And now we can tell that these triangles are congruent by side, side, side congruence. If I were to name the first one as ADC, you just have to have the matching order. So angle A is between the sides with 1 mark and the 3 mark. So in the other triangle, you've got to go find the 1 and the 3 and find the angle between there, which in that case will be C. So C matches with A for my congruent statement. The next one I put was D. D is between the side with the 1 and the side with the 2. So go find the 1 and the 2. So that leads me from C to angle B and then angle A. So you've got to match up your corresponding parts as you are writing that congruent statement. So just be certain that you are writing that in the proper order. The second one here, I have one angle and two sides in each triangle. And I have the two sides do not surround the angle, so it's not SAS, but it's SSA. Remember that this was not a proper reason for congruence, so we are not able to prove these congruent. So we're going to say not congruent or not enough information on that one. Over here we have vertical angles that we can add to the picture, so we will be using side, angle, side because we do have two sides and the angle between them. So side, angle, side is the reason, and if I say ABC for that top one, then for the bottom one, I would have to say EDC. The next one has some parallel lines. Remember that parallel lines will always give you angles. The parallel marking does not mean that those sides are the same length. You're going to use the parallel lines and the transversal in order to find angles that are formed by the parallel lines and that transversal. So that's going to be here and here. These would be congruent because if lines parallel, then alternate interior angles congruent. These triangles are also sharing a side in the middle there. that side exists in both of the triangles. So we can add that that is congruent to itself. And so we can see that the triangles are matching, and each triangle has 2 angles, and the side is between them. That's what gets me ASA for the reason. And if I say KNL for that top one, then I would have to say MLN. Just making sure your corresponding angles are all in alignment in that congruent statement. Remember that the statement of congruence can give you all your corresponding congruent sides and all your corresponding congruent angles just from looking at that congruent statement. Looking at number 3, we have some triangles in this problem where we are identifying the reason why they're congruent. One of the main things here is that we're using overlapping triangles. So we're going to have to name a pair of overlapping congruent triangles based off of the given information. We will state why we know they're congruent, and we will write a congruent statement. So in order to be correct here, I must use overlapping triangles, not just triangles that touch. So make sure they are overlapping, and when they're overlapping, they're going to have either a shared side or a shared angle that you're going to be using. So looking at this first one, they have right angles given, they have a congruent set of segments given, and the triangles that I see that use the givens here, I have a side and I have a right angle, and that leads me to this particular triangle that I'm highlighting in yellow, and it can be paired with this triangle over here that I'm using pink to outline. The double highlighted area can show you the shared item, which in this case is the segment WX. And so we could see that triangle ZWX should be congruent to triangle YXW by side angle side for the reason on that one. Looking at the next one, what is an issue on this one is that there's like layers of congruent angles here. For example, angle B is marked, the whole thing is marked, but also there's a small angle at B that is marked, so you have to be careful. If I were to highlight the full angle at B, it leads me to this triangle ABC, and then highlighting the full angle at C can lead me to this triangle BCD there. So I'm going to use these 2 triangles, and they share side BC. That's their overlapping part that they share and have in common. And if we were to sort of draw so we can see this better, triangle ABC would have the full angle at B, the little angle at C, and the shared side of BC. We would have the same thing for the triangle that I have highlighted in teal, just facing the other way. And so we're going to say triangle ABC is congruent to triangle DCB by angle side angle. And so that is that one. Looking over at this one here, we have some given segments. Let's see, LP is a segment in this triangle right here, and LO is in this triangle over here. If we were having to do a proof here, we'd have to do some segment addition to combine LP and PM to get segment LM. Should be a complex proof, one of the harder ones if we wanted to use that. M, L, and O are here. LO has the 1 mark. LM could be proved to be the same as LN because you would be adding LP and PM together. So we're able to know this side in our triangles. And the blue triangle and the pink triangle, the way they are overlapping, we can see that they share angle L at the top there. So angle L is our shared angle. And so we would be using side angle side for this triangle pair. So triangle NLP is congruent to triangle MLO by side angle side congruence. Again, it would be coming from putting these 2 pieces together, LP and PM, to create that second side that surrounds the angle that we have in common because of the overlapping part. There are 3 more overlapping, and then I'll do a different video for other problems. So in this one here, we have right angles given. So highlight that right angle. That leads you to the triangles on the bottom. So you've got that triangle on the bottom left, and you've got this triangle on the bottom right. These triangles, it depends on your given. These images could be used for the different sets of triangles in the picture. So it's all about what things are given to you. You want those to be included in your what you're using. These two triangles share side AD, and I could use hypotenuse leg to get them because they are right triangles. The hypotenuse of the right triangles is segment AD, and the leg that we know would be segment AB. Remember, if you're doing a proof with these, you would start with your perpendicular lines, lead to your right angles, and then from your right angles, since we're using HL, we would also have to say we have right triangles. So perpendiculars always give you 3 lines in the proof. So ABD is congruent to DCA by hypotenuse leg. Looking at the one next to there, we have an angle given and we have a side given. Looking at that angle, all of angle M is marked here, so that means this side to this side. And that leads us to this triangle JML over here for one of our triangles. This angle leads me again to the large angle there, creates that triangle on the right. These two triangles share side ML, so that can lead me to have side angle side. I should give that a double. They already had a single marking in there. Side angle side will be the reason. And the triangles, if I say JML, then I would say KLM. Over here, using our given, which is a little bit weird on this one. So one thing that I noticed when I saw this, like just right away, I noticed an isosceles triangle on the bottom. Remember that isosceles triangles, if you have two sides of a triangle congruent, then the angles across from them are congruent by the isosceles triangle theorem. So that gives me that angle at the bottom of that little triangle. Now, I'd like to find overlapping triangles that use the other given as well as what I was just able to find. And I can see that angle P is formed, or the angle at P that's marked, is formed by these two sides. And if I continue that side down to R, then I can pick up that angle that I just marked over there at R. So that creates that pink triangle there. And I can have another triangle if I outline Q, and that picks up the angle that I just got at S. And these two triangles have an overlapping side, which is the side SR. If I were to just sort of sketch out to the side here, one of those triangles to help me identify my reason. If this is PSR, then I've got one angle at P, I've got another angle at R, and I've got the shared side SR. And I can determine that this will be using angle side. And we can say that triangle PSR is congruent to triangle QRS. I know I'm running through these quickly, but this is because this is the review at the end. We've already studied this a whole lot of times, and you don't want to sit here watching these videos for hours and hours. Number 4 was a new problem compared to the old review, so let's look at it real quick. Given the following triangles, write the congruent statement and identify all the corresponding congruent parts. So we have every corresponding part marked in this picture. So this is what we did before we learned about the shortcut ways of proving triangles congruent. So the congruent statement, if I were to say ABC, then A is that right angle, it's got to match with F. B is the angle that has a little 1 arc, so that would match with G, and then H has a double which matches with C. So it's not about the alphabetical order, it's about matching up your corresponding angles to get your statement. And then you can use this congruent statement to come up with your corresponding angles and sides. So as I'm looking at this statement, assuming I wrote it right, we've got our matching angles all in order. A is congruent to F, B is congruent to G, and C is congruent to H. Corresponding sides, first 2 letters would be AB, would correspond to the first 2 letters. The second 2 letters would correspond to the second 2 letters. And the first and last would correspond to the first and last. Remember that they could switch the order on the letters of the segment, and it's still the same segment. So I'm just using the corresponding order of them from the congruent statement to get the two matching pairs of segments. So that is how I would use a congruent statement in order to list all my corresponding angles and all my corresponding sides.